direction of electric field, right? This is the uniform electric field, right? So this position I've described it as stable equilibrium, okay? And if you have a dipole which is the opposite direction to the electric field, right? So this we've described it as unstable equilibrium. Okay. Now oscillation ಆಗಬೇಕು ಅಂದ್ರೆ ಯಾವ type of equilibrium ಇರಬೇಕು? First of all, stable ಇರಬೇಕಾ, unstable ಇರಬೇಕಾ? For any object to undergo simple harmonic motion or oscillatory motion ಏನಾಗಬೇಕು? ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಪೊಸಿಷನ್ ಇಂದ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡೋಣ, ವಾಪಸ್ ಅದು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಪೊಸಿಷನ್ ಬರಬೇಕು, ಅದರಿಂದ ದೂರ ಹೋಗಬೇಕು. It has to come back to the equilibrium position. That's how simple harmonic motion works. Is that one stable equilibrium position is there? From that equilibrium position, if you displace it away from it, what will it do? It will try to come back to that equilibrium position. Okay. So about this equilibrium position, it will move back and forth. Right. So that's how you get simple harmonic motion or oscillatory motion. Now, E position ಅಲ್ಲಿ ಇದ್ದಾಗ oscillation agata, E position iddhaga oscillation, right? So what does electric field to do to a dipole is that electric field alli you dipole itre, it will try to rotate it in the direction of electric field. Okay. So now if you look at this, if you rotate it away from the electric field, what does the electric field do? It will try to rotate it back in the direction of electric field. If you rotate it in the opposite direction, what will it try to do? It will try to bring it back in the direction of electric field. So if you are displacing it by some angle, what is it doing? It is going to back and forth like this. So it is going to oscillate when it is in stable equilibrium position. If you talk about unstable equilibrium position, what happens if you simply rotate it by very small angle? What will it do? It will completely rotate and come to this stable equilibrium position. So E position ಇದ್ದಾಗ ಸ್ವಲ್ಪ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? It is not going to oscillate back and forth. It is simply going to rotate away from the equilibrium position. So ಇಲ್ಲಿ SHM ಆಗುತ್ತಾ? ಇಲ್ಲಿ SHM. Okay. So SHM ಆಗಬೇಕಂದ್ರೆ ಏನಾಗಬೇಕು? Dipole should be in what kind of equilibrium? Dipole should be in stable equilibrium. So now let's say this dipole is in stable equilibrium. Okay. So this is the electric field and this is the dipole. Okay. Now if I rotate it by a small angle, if I rotate it by a small angle in this direction, let's say that angle is theta. Okay. Now what is the torque that it experiences? Torque will be equal to P into E into sin theta. Now any simple harmonic motion is generally written for small displacements or small oscillations. So in this case, if this theta is very small, generally this sin theta is written as theta. But instead of plus theta, we will write it as minus theta. Why will we write it as minus theta? Now when I have converted this into this theta is what? Displacement. Okay, that theta is displacement. So displacement ಯಾವ direction ಇದೆ ನೋಡ್ರಿ? PE sin theta ಯಾವ direction ಇದೆ torque? So the torque is in the opposite direction to the displacement. See, displacement anti-clockwise. Anti-clockwise ಅಂದ್ರೆ direction ಏನು ಬರುತ್ತೆ? Outward. What is the direction of P cross E? P cross E means it is inside. Torque and displacement are in the opposite direction. Therefore, when you convert the sin theta into theta, you write it as minus PE into theta. Okay. Now, this torque is written as what? I into. How do you write this? Torque is equal to I into alpha. This is simply rotational law of Newton. Is it not? Newton translation law. F is equal to ma, rotation law, tau is equal to I into alpha. Now from here I alpha is equal to minus PE into theta. So from here you write alpha is equal to what? minus PE divided by I into, so for SHM, what you should have in SHM, or general equation of SHM is, general equation of SHM is what? General equation of SHM is alpha is equal to minus omega square theta. So comparing both of them, what you can write? You can write that omega square should be equal to what? PE divided by I. So from here you write omega will be equal to what? Under root of PE divided by I. Once you find omega, time period of oscillation ಏನಾಗುತ್ತೆ? Time period of oscillation T will be equal to 2 pi divided by omega. Yes, which will be equal to 2 pi under root of I divided by P. Yes. If you want one more step, 2 pi divided by under root of omega is how much? Omega is PE divided by I. So denominator will the root I will go in the numerator and you can write it as the root of I divided by PE. Okay. So for the heading time period of oscillation for a dipole. In uniform electric field. Right. So you have to note that dipole will oscillate about its what kind of position? Stable equilibrium position. Then dipole performs okay. So dipole oscillates about which position? Dipole oscillates about equilibrium position, and then dipole performs what kind of SHM? Dipole performs what? Angular SHM. It does not perform linear SHM. It performs what? Angular SHM. Angular SHM will remain bariera. You write this torque. Torque So what is P is what? Dipole moment. What is E? E is electric field intensity. This is the external limit. Then I is right. Omega ಅಂದ್ರೆ omega is what? Angular frequency, which is equal to under root of PE divided by I. So a lot of rotational mechanics concepts also are used here. Okay, if you understand rotational mechanics, there is that torque due to a couple can be written about any axis. Okay, torque due to a couple. So let's say this is the object. Okay, on this you are applying equal and opposite forces. Yes. Now this will create a couple, right? Now when they are creating a couple, let's say the perpendicular distance between them is L. Yes, the perpendicular distance between them is L. How do you write this torque due to a couple? Torque due to a couple, simply you write it as F into L. Yes. Now this torque, as it turns out, you can write it about any axis. You can take an axis passing through the center, or you can take an axis passing through this end, or you can take an axis passing through this end, or you can take an axis which is somewhere here or somewhere here. Okay. The torque that we are writing here because of a couple is actually independent of axis. Okay, that's the concept of torque, is that the axis ಮೇಲೆ depend ಆಗಂಗಿಲ್ಲ. Okay. Almost completed. We were at this point, yes. An electric dipole is situated In electric field of uniform intensity E, whose dipole moment is the electric dipole moment P there, it is placed in, and the moment of inertia of that is I. If the dipole is displaced slightly from the equilibrium position, angular frequency is what? Angular frequency is omega. So omega is under root of Pe by I. Omega is under root of Pe by I. Okay. An uncharged sphere of metal made of metal is placed in between two charged plates. Okay, the lines of force look like you have one positive and you have a negative, right? I've shown how do you draw electric field lines when you have a positive plate and a negative plate. It will be from positive to negative straight line. Okay, but now after that, what they've done is they have placed a metallic sphere, okay, in between them. Conductor properties and over. Yes. Conductor properties electric field is the 0, and on the surface the electric field will be always perpendicular to the conductor. If you have a conductor like this, right, if you see what is the electric field on the surface here, it should be perpendicular to the surface like this, right? Both of these points we have discussed, right? So if you take both of these into consideration, B antara agangilla, because electric field is passing through the between A, C and D. This A. Thus, if you talk about electric field lines, this they are not what? They are not perpendicular to the surface. So this is also not possible. So if you take electric field lines, this one. So this is not perpendicular to the surface here. The only possible option is this. Okay. If you take electric field lines at any point, they are actually what? They are actually perpendicular to the surface. Okay, so these positive charges will induce negative charge here, and then these negative charges will induce positive charge here. So what happens is you have something like this: a negative charge at the top, positive charge at the bottom. So you will have then so from positive to negative, from positive to negative. So from positive to negative on the surface, and from positive on the surface to the negative of the plate. Okay. An electric dipole of dipole moment P is placed on x-axis. Okay, so let's say this is your x-axis. So dipole is placed what? A dipole is placed on x-axis. Okay. The electric field at a point P. Electric field at a point P whose position vector makes an angle theta with x-axis. Okay. ಯಾವುದೋ ಒಂದು ಪಾಯಿಂಟ್ P ಇದೆ ಇಲ್ಲಿ. Yes. And the position vector of this point P with respect to dipole ಹೆಂಗ್ ಡ್ರಾ ಮಾಡ್ತೀರಾ? Dipole center ತಗೊಂಡು from the dipole to this point you draw this. This is what? This is your position vector. This is your position vector. Okay. ಈ position vector ಏನು ಮಾಡ್ತಾ ಇದೆ? ಈ position vector it is making an angle of theta. This position vector is making an angle theta with x-axis. Okay. Whether it is making angle theta with x-axis or with a dipole, ಎರಡು ಒಂದೇ ಅಲ್ಲ, because dipole is placed along x-axis. Will make an angle of phi with the x-axis. What is making an angle of phi with the x-axis? The electric field. The electric field at a point P whose position vector. A point P is the position vector is position vector angle theta, and then electric field angle ಏನಾಗುತ್ತೆ? Electric field angle is phi. So how do you draw the electric field at this point? The net electric field is something like this. Let's say. Okay. So this is making an angle of phi. Then extend madre. So here this is the angle which is making with x-axis. This angle is given as phi. What is they given? They are given that if tan alpha is equal to 1 by 2 times tan theta, where alpha is the angle between electric field vector and position vector. Okay. See position vector na ee ತರ extend ಮಾಡಿದ್ರೆ, where is the angle alpha? Okay. Now what are they asking? Then the angle phi that the electric field makes x-axis is. They are asking what is this in terms of theta and alpha. Okay. So this is the position vector. That position vector is making an angle alpha with the electric field, and this electric field is making an angle of phi with x-axis. Right. So if you look at this triangle, ಈ triangle ಅಲ್ಲಿ ಈ angle alpha ಅಂದ್ರೆ ಈ angle alpha ಆಗುತ್ತಾ? Yes. Now for this triangle, this phi is an external angle, right? So external angle is equal to sum of internal angles. So from here you write that phi is equal to what? Theta plus alpha. Yes. Okay. Oh, we've already done this. Yes. 32 and 64. 32 and 64. Okay. Fine. Okay. The magnitude of the intensity of the electric field at a distance x on the axial line and at a distance y on the equatorial line, okay, for a given electric dipole are equal. The ratio of x is to y is. Okay, let us try this. Yes. axial line ಮೇಲೆ x distance ಅಲ್ಲಿ equatorial line ಮೇಲೆ y distance ಅಲ್ಲಿ electric field same ಇದೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದಾರೆ. They are asking to calculate the ratio of x and y. Okay, so you have to take the formula for short dipole. Okay, then calculate what is the ratio of x is to y. So if you take normal dipole, x raised to x is to y calculate ಮಾಡಲು difficult ಆಗುತ್ತೆ. D? Even if you don't know, you can directly guess cube root. Okay. So axial line ಮೇಲೆ what is the electric field? 2 kp divided by r cube. R cube here, r is given as x. So can I write it as 2 kp divided by x cube? And what is the formula for equatorial? Equatorial simply kp divided by r cube. R in this case is y. Since they are only talking about magnitude, minus sign ಬರಿತಾ ಇಲ್ಲ. Okay. So ಅವ್ರು ಏನು ಹೇಳಿದ್ದಾರೆ, x distance on axial and y distance on equatorial ಎರಡರದ್ದು electric field ಏನಿದೆ, ಎರಡರದ್ದು electric field equal ಆಗಿದೆ. If it is equal, I can write it as 2 kp divided by x cube should be equal to kp divided by y cube. So from here, what do they want? They want x is to y. So you do 2 is equal to x cube divided by y cube. So from here you can write x is to y is equal to cube root of 2 is to 1. This will be option. Is this fine? Right, x distance on the axial line, y distance on the equatorial line, electric field is same. X is to y will be cube root of 2 is to 1. Try this one also. The electric field intensity due to a dipole of length 10 centimeter having a charge of 500 microcoulomb at a point on the axis at a distance of 20 centimeters from one of the charges in air is. Okay. Read this question. First tell me which formula you will use. You will use the short dipole formula or the regular formula? See again. Dipole length is 10 centimeters. A distance from the dipole is. So here you cannot use short dipole formula. Short dipole formula distance ಏನಾಗಬೇಕು 10 centimeter compare ಮಾಡಿದ್ರೆ this distance should be very very large. So let's say they have given it as 20 meters. Yes, if they have given it as 20 meters, then you would use formula for short dipole. But the distance from the dipole is 20 centimeter. Dipole length itself is 10 centimeter. Short dipole formula use ಮಾಡಕ್ಕೆ ಬರಂಗಿಲ್ಲ ಇಲ್ಲಿ. Okay, so you have to use what? You have to use so axis formula ಏನದಪ್ಪ? Axis ಮೇಲೆ short dipole formula is very easy. This one is sorry, you have 2 kp into x divided by a square minus x square whole square. X ಅಂತ ಬರ್ದಿದ್ದು r ಅಂತ ಬರ್ದಿದ್ದು. we take it as r, we take it as x. Distance from the dipole. Okay, this like that. Formula name 2kpr divided by r square minus 2kpr divided by r square minus a square whole square. Okay, so first of all, draw the diagram for this. Electric field due to dipole. So minus plus, let's say. Okay, what is the distance between them? The distance between them is 10 centimeters. Okay, and then what is the point? The point is at a distance of how much? The point is at a distance of 20 centimeters from where? From the center. So distance from another. So can I take that this is the point, and what is the distance of the point? The distance of the point is 20 centimeters. Illi electric field ಎಷ್ಟು ಅಂತ calculate ಮಾಡ್ರಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಹೌದಾ? Yes sir. What is it saying? You have a dipole minus plus. Distance between them is 10 centimeters. One the charge in the axis ಮೇಲೆ it is at a distance of 20 centimeters. Okay. Now, what is the value of A? If this is the dipole, what is the value of A? What is the value of A? 5 centimeters. Okay. Then what is the value of R? R is measured from where? R is measured from center of the dipole. R is measured from center of the dipole. Center of the dipole in the position ಎಷ್ಟು ದೂರ ಇದೆಪ್ಪ ಇದು 20 plus this 5 ಅಂದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? This becomes 25. Okay. And what is the charge on each of them? Charge on each of them is given as how much? 500 into 10 power minus 6. ಇದು 5 centimeter ನಾನು 5 into 10 power minus 2 meter. This 25 centimeter I write it as 25 into 10 power minus 2. So what will be the value of dipole moment P? Q into 2A, which will be what? 500 into 10 power minus 6 multiplied by 2A andre 10 into 10 power minus 2. Using all of those electric field on the axis, that point in another 2 kp, 2 into, so 2 into what is the value of k? K is 9 into 10 power 9 multiplied by p. What is the value of p? P is 500 into 10 power minus 6 multiplied by 10 into 10 power minus 2 multiplied by what is the value of R? R is 25 into 10 power minus 2 divided by R square minus A square whole square. R square is 25 into 10 power minus 2 square minus A square is 5 square into 5 into 10 power minus 2. ಇದು ಪೂರ್ತಿ ಮತ್ತೆ ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕಾ? Okay. See here, 10 power minus 2, 10 power minus 2 square, if you take it outside, what you will get common? 10 power minus 2 square ಮಾಡಿದ್ರೆ 10 power minus 4. ಇಲ್ಲಿಂದ 10 ಪವರ್ ಮೈನಸ್ 4, ಇಲ್ಲಿಂದ 10 ಪವರ್ ಮೈನಸ್ 4. ಎರಡರಲ್ಲೂ ಕಾಮನ್ ತಗೊಂಡ್ರೆ ಮತ್ತೆ ಸ್ಕ್ವೇರ್ ಮಾಡಬೇಕಾ? ಮತ್ತೆ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ರೆ ಹೊರಗೆ ಬಂದ್ರೆ ಏನಾಗುತ್ತೆ? 10 ಪವರ್ ಮೈನಸ್ 8. So this will be 10 power minus 8 is into this is 25 square minus 5 square. Yes sir, 25 square 625, 5 square is 25, 600 agata, 600. Okay. Numerator again. 2 into 9 into this is 5 into this is 25. ಉಳ್ಕಿದೆಲ್ಲ 10 power. This is 10 power 9, 10 power 2, 10 power 11, 10 power 11 minus 10 power 10. It's 10 power 1. Further calculation ಮಾಡಿದ್ರೆ ಎಷ್ಟಾಗುತ್ತೆ? So 10 power 4, 10 power 5 ಆಗುತ್ತೆ. This is 2 into 9 into 5 into 25 divided by 6 into 6 into 10 power 5. 6 1s are 6 3s are 18, 3 1s are 3, 2s are 6. Okay, so this is 2 1s are 2, 2.5. Okay, so this is 25 25 625 625 1.62.5. So this is 62.5. 10 also is there, na? No, 10 also is done. 10 power minus 8, 10 power 4 is 10 power minus 4, 10 power minus 4 millimeter, 10 power plus 4 into 10, 10 power 5. Ah. 10 raised to minus 7 you are getting, raised to minus 6 you are getting. Nine, 10, 11. 11 minus 10 is 1. 10 raised to minus 8. Ten raised to 2 whole square, you get 10 raised to 4. Here you get 10 raised to 4. 10 raised to 2 you get 9, 10, 11. 11 minus 10. Oh, there is one more 10 here, na? Oh, there is one more 10. 10 into. Yeah. So that is the case. So this will become 10 raised to 6. So 62.5 into 10 raised to 6. So this becomes what? 6.25 into 10 raised to 7. Calculation is ಸ್ವಲ್ಪ lengthy ಆಗ್ತದೆ, but otherwise it is simple. Yes, dipole is given, plus and minus. Distance between them is 10 centimeters. Distance between them is 10 centimeters andre 2a is actually equal to what? 10 centimeters. So andre a estagutte? A will become 5 centimeters, and because the point is at 20 centimeter from one of the charges, R will not be 20. R is measured from there, R is measured from center. So since it is measured from center, center in the distance estaಗುತ್ತೆ 20 plus 5 it will become 25. Charge Q ಕೊಟ್ಟಿದ್ದಾರೆ 500 microcoulomb, that will be 500 into 10 power minus 6 coulomb. Okay. If you want to calculate what will be the dipole moment will be P Q into 2A. Q into 2A is 500 into 10 power minus 6 into 10 into 10 power minus 2. Using the formula 2 kpr divided by r square minus a square whole square. Okay. ಯಾಕೆ ಈ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋತಾ ಇದೀವಿ. ಯಾಕಂದ್ರೆ ಇದು 10 centimeter, the distance is 25 centimeter. ಎರಡು they are not big difference. Okay. Shall we look at next one? Yes. Yes, I think you can just tell me. Direct molecule with the dipole moment P is placed in electric field E. Initially, dipole is aligned what? Parallel to electric field. Parallel to electric field. Work done ಕೇಳ್ತಾ ಇದ್ರಲ್ಲ, work done ಕೇಳಿದ್ರೆ theta 1 theta 2 ಬೇಕು ಅಲ್ಲ. theta 1 ಏನಾಗುತ್ತೆ parallel ಇದ್ರೆ 0 degree, theta 2 anti parallel ಆಗ್ತಾ ಇದೆ. Anti parallel ಅಂದ್ರೆ it is 180 degree. 0 to 180 ಹೋದ್ರೆ the work done will be plus 2 PE. Okay. This also already done. Yes. Angular frequency. Yes, angular frequency is under root of PE by I. Under root of PE by I. Okay. The electric field E at a point R vector on the axis. Axis mele is it in the direction of dipole moment or is it opposite to the direction of dipole moment? It is in the direction of dipole moment. In the direction of dipole moment ಅಂದ್ರೆ electric field ಏನು ಬರುತ್ತೆ? It is 2k p vector divided by r cube. 2k p vector divided by r cube is option A. Action. Okay. Non-uniform. We have learned about uniform. What happens when you place electric field, dipole in a uniform electric field? What happens? What does it experience? Right? It will not experience any net force, but it will experience what? Net torque. Okay? Yak net force irangilla. If you have this dipole minus Q and this is plus Q. So idar mele force estagutte? Q into E. On this also the force will be Q into E. But idar mele if it is towards right, on this it will be towards left. And both the forces are equal in magnitude. Plus QE minus QE ಎರಡು add ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ net force ಅದರ ಮೇಲೆ 0 ಬರುತ್ತೆ. This is the case when the electric field is uniform. Uniform ಅಂದ್ರೆ ಎಲ್ಲ ಕಡೆ electric field same ಇದೆ. Non uniform ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? Electric field is not uniform, which means minus Q electric field E1 ಅಂತ experience ಮಾಡಿದ್ರೆ plus Q will experience what? A different electric field E2. Yes, negative charge, if it experiences electric field E1, positive charge will experience a different electric field called as E2. Okay? Because it is a non-uniform electric field andre ella point alli bere bere electric field. Okay? So since minus Q and plus Q, they are not placed on the same point. Dipole alli ಎರಡು same point alli irtava. minus q ಒಂದ್ ಕಡೆ ಇದ್ರೆ plus q ಇನ್ನೊಂದ್ ಕಡೆ ಎಲ್ಲೋ ಬೇರೆ ಕಡೆ ಇರುತ್ತೆ. Yes sir. So therefore since they are both not placed at the same point, ಏನಾಗುತ್ತೆ electric field ಇದರ ಮೇಲೆ ಬೇರೆ ಬೇರೆ. So ಇದರ ಮೇಲೆ ಬೇರೆ ಬೇರೆ ಇದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ in this case net force will not be equal to, and net torque anyways so if it is placed in a non-uniform electric field, what will happen is it will experience what? It will experience a net force and also a torque. ಬರೀ ನೆಟ್ ಫೋರ್ಸ್ ಅಷ್ಟೇ ಇರಂಗಿಲ್ಲ, ಅದರ ಮೇಲೆ ನೆಟ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ಮತ್ತೇನಿರುತ್ತೆ ನೆಟ್ ಟಾರ್ಕ್ ಆಲ್ಸೋ ವಿಲ್ ಬಿ ದೇರ್. ಓಕೆ, axial to equatorial, axial divided by equatorial ಅಂದ್ರೆ 1:2 ಆಗುತ್ತೆ, 2:1 2:1. ಓಕೆ, yes, the magnitude of a charge on an electric dipole is how much? 3.2 into 10 power minus 19, and the distance between them is 2.4 angstrom. If it is placed in an electric field of 4 into 10 power 5, the dipole moment is, dipole moment calculate ಹೆಂಗ್ ಮಾಡ್ತಾರೆ? P is equal to charge multiplied by distance between them. What is the charge? Charge is 3.2 into 10 power minus 19 multiplied by what is the distance between them? 2.4 angstrom. 2.4 angstrom andre angstrom is 10 power minus 10. Okay, angstrom is 10 power minus 10. So if you multiply these, what do you get? 10 power minus 29. Yes, 10 power minus 19 into 10 power minus 10, it is 10 power minus 29. Yes, electric field information ಏನಾದರೂ ಬೇಕಾಯ್ತಾ ಇಲ್ಲಿ? Electric field information ಏನಾದರೂ ಬೇಕಾಯ್ತಾ ಇಲ್ಲಿ? No. This is what, this is simply a useless information. Just to simply confuse you, so ಆ ವ್ಯಾಲ್ಯೂ ತಗೊಂಡು ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು, ಏನೋ ಯೂಸ್ ಮಾಡ್ಬೇಕೇನೋ ಇಲ್ಲಿ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ. ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋದಕ್ಕೆ ಏನ್ ಬೇಕು? ಚಾರ್ಜ್ ಬೇಕು, ಎರಡು ಚಾರ್ಜ್ ನಡುವೆ ಡಿಸ್ಟೆನ್ಸ್ ಬೇಕು ಅಷ್ಟೇ. ಆಲ್ರೆಡಿ ಅವೆರಡು ಕೊಟ್ಟಿದ್ದಾನೆ, ಡೈಪೋಲ್ ಡೈರೆಕ್ಟ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು, ಅಷ್ಟು ಬರುತ್ತೆ. Done this. Yes, it is 5 centimeters. Yes, 25 centimeter distance is it? P and okay. And this. When will the torque be maximum? Dipole moment is placed in electric field. Maximum torque ಯಾವಾಗ ಆಗುತ್ತೆ? When the angle between them is 90 degree. What is the angle between electric dipole moment and the electric strength due to it? The equatorial line. Equatorial line ಮೇಲೆ 180 degree. ಹೌದಾ? Opposite direction ಇರುತ್ತೆ ಅಂದ್ರೆ ಏನು? Angle between them will be 180 degree. Equatorial line ಅಂದ್ರೆ ಇದು ಮೇಲ್ಗಡೆ ಹೆಂಗಿರುತ್ತೆ? ಉಲ್ಟಾ ಇರುತ್ತೆ. Yes, maximum torque between them is 1:x. So maximum torque 1 divided maximum torque 2 will be what? P1 divided by P2 E2. P1 is 1.2 into 10 power minus 30 multiplied by 5 into 10 power 4 divided by P2 is 2.4 into 10 power minus this is 30, yeah, multiplied by 15 into 10 power 4. ಏನಾಗ್ತೈತಪ್ಪ 1:2 1:3 which is coming out to be 1:6. So 1:6 is equal to 1 by x. So therefore x is equal to maximum dipole moment. ಒಂದಕ್ಕೆ PE, ಇನ್ನೊಂದಕ್ಕೇನು PE. Okay, one of the PE is 1.2 into 5, another PE is 2.4 into 15. Into the ratio ತಗೊಂಡ್ರೆ 1 by 6 ಬರುತ್ತೆ. 1 by 6 equal to 1 by x is equal to